The history of deep sea oil drilling began when Henry L. Williams and his associates began constructing drilling rigs out on piers out into the Pacific Ocean in Summerlin, California. Once these drilling piers began to hit oil, companies started to invest in these piers. By 1911, the Gulf Refining Company abandoned their piers and started to produce platforms that would drill out into the middle of lakes. They started to drill out in Caddo Lake, which is a lake in Louisiana, and the success of these drilling platforms, they became wildly successful, and they started to produce oil at a rate of 450 barrels per day. This number may seem pedestrian by today's standards, but back then it was revolutionary. Then companies like Pure and Superior began to move further and further out into the ocean, like exclusively the Gulf of Mexico, utilizing the shallow depths of the Gulf of Mexico at large distances, and began to construct stationary platforms to exploit the oil salt domes, which was the geologic formation in the Gulf of Mexico, which is a geological stratification that would trap oil within the rock layers. But due to the stationary nature of these rigs, the risk of running into a dry well definitely outweighed the costs of constructing these platforms, which required the industry to develop mobilized drilling rigs. So companies like Kermac-McGee developed rigs such as the Kermac rig number 16, which would be able to drill in one location, then move to a next, and next, and the next, which made the industry take off. And eventually, oil became the second largest revenue generator in the United States after income taxes.
Okay, when discussing offshore oil drilling, there's many concerns that arise. These concerns include major accidents or oil spills that can occur. However, there are also aspects of a drilling rig that are harmful to the environment in an everyday operation. These include exploration techniques that are harmful to marine mammals. They can cause them to become disoriented and affect their ability to communicate with one another. And also there's everyday leaks, and harmful waste can be washed off the decks, and chemicals can be released into the atmosphere. More complex technologies and equipment are also required for the deeper drilling. So shallow water accidents, there's usually only one for every 272 wells. For deep water drilling, there's about an accident every 1 in 35 wells, and for ultra deep water wells, there's about an accident 1 in every 15 wells. There are, of course, major spills and accidents are a major concern, and the greatest example of this is the Deepwater Horizon incident, which occurred in 2010, where over 210 million barrels of oil were released into the ocean. It's the largest spill in the oil industry history.
So as you all know, the global demand for oil is constantly increasing. This has facilitated the expansion of the oil industry into deep and ultra-deep water drilling. Due to the influx of sediment from surrounding areas, underwater oil reservoirs are often the largest sources of oil, as well as the most untapped potential. With this increase in demand, companies must remain diligent with safety precautions as to avoid lasting environmental damage. When choosing a site, the rigorous subsurface investigation done by the drill crew is often not enough. The drill team must also conduct checks on the pore pressure and fracture pressure gradients of the subsurface. For this, they use one of two tests, either a leak-off test or a formation integrity test, both which compare test values found in the subsurface conditions to pre-calculated thresholds. During the drilling process, the mud weight pressure within the well must remain between the pore water pressure and the fracture pressure as to avoid well collapse. This specific mixture, called drilling mud, is a combination of mud, oil, water, and several other additives. This is used to help cool the drill bit during the drilling process, as well as circulate the cuttings out of the way. Since it is not just water, it must be pumped back up and contained on site. Once a certain depth is reached, concrete cylinders must be used to help support the self-weight of the mud well walls. These cylinders are called casings and are lowered into the holes once a certain depth has been reached. Once the desired depth has been reached, cement is pumped down the casing and out the bottom of the drill string, and up, back up the well and sets. Once it sets, the borehole will be sufficiently supported for normal drilling operations. Final step to prepare the hole is for the oil removal process is the installation of both the wellhead and the blow-off preventer. The blow-off preventer consists of several attachments that serve as a last line of defense should the pressures within the well grow too high. The top attachment, and most important, the blind shear ram, will theoretically shear the entire casing, thus blocking the flow of oil upward should a failure occur. When not drilling, the pipe is disconnected from the wellhead as to avoid for unnecessary damage. Next slide. Oh, no, I missed it. So for our first case study, we chose to do an investigation of the largest semi-submersible oil rig in the world. The Maersk Explorer, owned by a Danish company, Maersk, is located in the Caspian Sea, one of the most up-and-coming sites for oil production. It is off the coast of Baku, the capital of Azerbaijan, and was completed in 2010. It was opened for use at the end of 2012 and is estimated of a maximum of up to 9 billion cubic feet of oil annually. Next slide. Here, as you can see, it's a pretty massive structure. Total deck area is about 44,000 square feet, and everything on site is powered by 4 AMG diesel generators. Okay. The underwater pontoons, as you can see, are filled with water and are partially submerged as to keep the structure floating as well as stationary. Since it is partially submerged, they make it useful in bad weather. I'm done with this. Okay. The rig uses 2 separate processes to stay in place, using both ground anchors and thrusters. 4 thrusters are located at the corners of each pontoon, and they use GPS location technology to keep the rig in the same location. The ground anchors are a series of 8 anchors placed radially around the rig beneath the ocean floor and are connected to the rig using high-tension cables. These act as a last line of defense to keep the pipe relatively vertical down from the rig. Yeah, so next slide.
Okay, our next case study examines a theoretical drilling operation off the coast of British Columbia and the costs and revenues that will result. There is currently a moratorium imposed by the Canadian government which prohibits any offshore drilling off the coast of British Columbia. This has been in place since 1972. Research continues to be done in order to determine whether or not this should be lifted. Offshore oil drilling permits are currently issued by Canada and Newfoundland and Labrador. Drilling in this region has a safer track record than that in the U.S., with only 1 spill of more than 50 barrels occurring since the operation began due to stricter regulations within the United States. The Geological Survey of Canada estimates that there are 9.8 billion barrels of oil that are available in the Queen Charlotte Basin off the coast of British Columbia, seen in the image on the right, and with drilling depths ranging from 700 to 1,400 feet below sea level. The major financial concerns with allowing oil drilling in this region is the large upfront costs with no immediate revenue, and large spills or accidents would not only be harmful to the environment, but they would also be extremely costly and could end a project. Other environmental concerns include the effect of drilling and seismic surveying on marine life and greenhouse gas emissions that will occur. Okay, this figure shows the expected costs and benefits from the offshore drilling operation. This theoretical example determined its projection based off one project that could produce for 28 years, located in the 2nd largest oil reservoir in the Queen Charlotte Basin. For the first 12 years from the start of the project, there would be no oil produced. This time would be dedicated to seismic surveys to locate the oil, mobilization, exploratory wells, constructing a production facility and transportation methods, and drilling the well to reach the oil. The project would produce oil from the year 12 to 25, with demobilization occurring until year 28. Assumptions in these projections include medium spills throughout the entire project and a frequency that's based off current drilling operations in the Gulf of Mexico, and the economic impact of a large spill is also accounted for, seen in year 18. If no large spill were to occur over the course of this project, the expected net benefit would be $24.3 billion, and with a large spill occurring at the 18th year, the benefits would drop to $18.6 billion, assuming the production continued after the spill. The revenue and cost values are also assumed based off the value of the Canadian dollar in 2010 and projected oil prices.
My case study involved the varying regulations involved pre and post the BP oil spill. So basically all offshore drilling occurs with what is known as the EEZ, which is the Exclusively Economic Zone, which is a U.S. territory where the U.S. owns all the rights to explore, exploit, and manage the natural resources within this zone. So all the oil companies that operate within the EEZ must abide by the American regulatory agencies such as the Department of Interior or the OPA, the Oil Pollution Act. The Department of the Interior requires oil companies pre-BP oil spill to purchase like 5-year leases that say that they're going to explore a certain area, and they must submit an exploring plan. And once that's approved, and an oil is found, that they must the Department of Interior has to approve of their plan to develop and produce the oil found at this site. Oil companies have their own regulations that were highly secretive due to the competitive nature of the field, and because of this, there was not a lot of transparency within the industry pre-BP, and the only disclosure of protocols happened when regulatory agencies required them to show their protocols. And because of this, there's a lot of gray areas between the regulations, and there's also a gray area due to the distance at which these oil drilling rigs are located. There's an inverse relationship between the regulation and the distance from the coast, and this is due to cost, as resources are resources are diminished in value the further off the coast they get, due to regulatory expenses increasing. After the BP oil spill, the Obama administration said that we had enough, and they instituted the National Commission for Deep Sea Oil Exploration, and essentially this kind of improved regulations on the industry. It demanded that both governing agencies and the oil companies themselves take unilateral steps to improve their regulatory policies, kind of implementing self-policing policies regarding the oil industries. And they also added government incentives to improve technologies associated with the risk of drilling at deeper and deeper reps, while also providing government incentives to improve the scientific field or the environmental nature of the Gulf of Mexico. And then one of the important regulations was the principle of high consequence, low probability events, which essentially means that the oil companies, when coming up with a new project, have to present it to the governing agencies based on a risk number, and this would be approved by the Department of Interior, for instance.
So in summary, the deep sea oil industry is growing due to the always increasing oil demand of the way our culture is run. Industry growth facilitates the technological advancement, but that also leads to the importance of the growth of the regulatory measures needed as well. It's a high risk, high reward kind of situation, as we saw in the BP oil spill. There's always a high risk when drilling at such great depths, but the reward is great profit margins. Regulation of the industry presents its own complications, but it must stay on par with international market as to protect the environment. Any questions?